This is a preview for the class that's going to come up Tuesday of this week, where we're going to be discussing projectile motion. Here it's strictly figurative. I have a cannon shooting some projectile with an initial velocity vi at some angle theta. Okay, my x is along positive to the right, my y is positive up, and my initial position is figuratively in this example going to start from the ground. So this will be important in understanding later on if the projectile is fired from a different elevation, then then some of the constants when you integrate are going to change. But I'm not going to get into great detail. I'm just going to show you an example of how to figure out motion in the x direction, motion in the y direction with a projectile object launched from the ground. Okay, so what we need to understand is that in the x direction there is no acceleration. Okay, it's zero. It's x double dot is equal to 0. The only acceleration we're going to have is due to gravity, and when we get into explaining the y direction measurements, then we'll evaluate that. But there's no acceleration in the x direction. The only thing we do have going in the x direction, well, there's two things we have. We're going to have a speed, and it's going to travel a distance. So its speed is the initial velocity times cosine theta. So in regards to the x direction, its speed is the initial velocity cosine theta, which kind of makes sense. You look at it, it's at some given angle, and it's being fired off with an initial velocity. So naturally, in the x direction, to find that component, it should be the cosine of this angle. And to find out the distance traveled is the initial velocity cosine theta times time, because position is nothing more when under constant acceleration. In this case we do have constant acceleration, it's 0. There's nothing more than speed times time. So that's why that gives us the distance. That's the range, if you will. For the y direction, we have y marked positive as going up, so the acceleration due to gravity is negative g. Now, the speed in the y direction is negative g times t plus the initial sine theta. Now, I'm not going to go into explaining velocity or position in the y direction, because I think it's most appropriate that we have that done in class, but I do want to show you the equation in advance, so this way you have an understanding of it on something to think about beforehand on class come Tuesday, so when he does explain it, it all clicks. So the next point is in the y, if we wanted to figure out the height or the altitude of the object, that is 1/2 gt squared plus vi sine theta t. So in order to encourage the thinking process to understand how these equations are derived, just remember that v is dx dt and acceleration is dv dt. So look at how these translate back and forth to one another in their respective areas when you integrate or differentiate with respect to time.